Welcome to the Deep Dive. We unpack complex ideas, aiming to give you the insights you really need.
And today, we're tackling some truly big ones.
Yeah, think about the biggest questions out there. How did it all begin? The universe, I mean.
How might it end?
And those mysterious things. Black holes. What are they, really?
It's a journey right to the edge of what we know. And our guide. Well, it's Stephen Hawking's incredible book, A Brief History of Time.
That's the one. We've based this deep dive on a comprehensive review of that very book. Our mission really is to unpack its genius.
And its lasting impact.
Exactly. We want to show you why it grabbed millions of readers and why it's still so relevant today. For anyone curious about the cosmos,
Doesn't matter what your background is.
not at all. So expect us to explore not just the science bits.
So we'll definitely cover those.
Oh, yeah. But also the story behind it, all the human curiosity driving it.
The way Hawking tells the story is unique, too.
Right. His style. And crucially, how digging into these huge ideas can actually benefit you, our listener. Different ways for different people.
Okay, let's dive in then.
Right. A Brief History of Time came out in 1988 and boom, became one of the most influential popular science books ever.
It really did.
So what was Hawking really aiming for? What was the big ambition behind it?
Well, it was incredibly bold. He wanted to explain the universe's biggest secrets, the Big Bang, black holes, all of it.
To just anyone, the average reader.
Yes, exactly. And the key thing, without drowning them in heavy mathematics. No dense equations.
That sounds almost impossible for this kind of topic.
It was ambitious. He really tried to, let's say, democratize cosmology, make it accessible.
Okay, so people talk about the genius of the book.
Yeah.
What does that actually mean in practice? What made it stand out beyond just simplifying facts?
That's where it gets really interesting. It's how he does it. He balances this mind-bending complexity.
With just basic human curiosity.
Precisely. Take the Big Bang. He doesn't just list facts. He frames it more like humanity solving a cosmic mystery.
Like a detective story.
Kind of, starting with clues like the redshift in galaxies, then building up to things like the cosmic microwave background.
Okay.
It's that narrative approach, even within the science, that pulls you in. You feel like you're part of this grand quest for understanding.
He really did make the universe feel approachable. But how did he structure it? I mean, these are huge ideas. How did he organize them so you don't just get lost?
That's another part of its brilliance, the structure. He sets it up like a journey, an intellectual expedition.
Chapter by chapter.
Yeah, concise chapters. Each one builds on the previous one, like stepping stones leading you deeper.
Makes sense.
He kicks off with, our picture of the universe shows how our understanding grew, from ancient ideas, Aristotle,
Right.
all the way up to Einstein's breakthroughs, laying the foundation.
Okay, so that's the starting point. Where does he take us from there?
Then he jumps right into the core of modern physics. Space and time. Introduces relativity.
Which completely changed how we think about space and time, not fixed anymore.
Exactly. Dynamic, they can warp, stretch. And then smoothly, he moves to the expanding universe.
The Big Bang again.
Right, but explaining it as this compelling story backed by real evidence. Our universe is getting bigger, it flows logically, building complexity step by step, that's key.
And from the huge scale of the universe, he zooms in.
He does. Right down to the quantum realm, discusses the uncertainty principle.
Which is always a bit mind-bending. Limits on what we can even know.
And then he breaks down elementary particles and the forces of nature.
How does he make that relatable? Tiny particles?
It's impressive. He shows how their interactions govern everything, from stars to us, but without relying on the math. He focuses on the concepts.
And then we get to the big one, black holes, the thing he's maybe most famous for.
Absolutely. He covers how they form, their properties, and crucially, his own huge ideas, like Hawking radiation.
Ah, yes. And that leads to that fascinating chapter title, Black Holes Ain't So Black. He's challenging the pop culture idea, right?
He totally is. It was revolutionary. The idea that black holes aren't completely black boxes.
They leak, emit particles.
Tiny amounts, yes. They can actually radiate energy and over immense timescales, sort of evaporate.
Oh, wow. That changes everything.
It really did. From there, he broadens out again to the origin and fate of the universe, discussing theories on how it all started and where it might be headed.
And then there's time itself.
Yeah.
The arrow of time. Why does it only seem to go one way? Forward.
That one really makes you think, doesn't it? Is our everyday experience of time real or just perception?
It lingers with you.
Definitely. Changes how you see things. And finally, he talks about the unification of physics.
The ultimate goal.
The search for a single theory of everything, something that connects the big stuff, relativity, with the small stuff, quantum mechanics.
And he wraps it up with a conclusion.
Yep. Reflecting on humanity's place in it all and why we need to keep exploring, keep asking questions. It's quite a journey he takes you on.
It really sounds like it. So beyond the science, the facts,
Yeah.
what are the deeper takeaways? The core messages Hawking wanted people to grasp.
Well, one big one is definitely this. The universe is knowable.
Even the really weird parts.
He insists on it. Things like black holes, quantum weirdness, they can be understood, at least in principle, without needing a PhD, if explained clearly.
Which says something about our own ability to understand, maybe.
Exactly. It empowers you, makes you think, okay, maybe I can wrap my head around this.
He also talks about science as a human story,
Yeah.
right? Not just equations.
Absolutely. It's not just dry facts. It's the history of those facts.
Yeah.
How we went from myths to math. It makes science feel like this grand, ongoing human adventure.
That's a much more engaging way to learn it.
For sure. And then there's that central challenge he highlights, bridging the divide.
Between the big and the small, Einstein and quantum mechanics.
Right. General relativity for gravity and the cosmos, quantum mechanics for particles, they don't quite fit together yet.
And finding a theory that unites them is the ultimate prize in physics.
It's the holy grail. And what's amazing is how Hawking makes this huge abstract challenge feel relatable, feel important to everyone.
And you mentioned the enigma of time earlier. That runs through the whole book.
As a constant thread, from the Big Bang's beginning to how black holes might evaporate, it forces you to question your assumptions about time. Is it fundamental? Or an illusion?
Deep stuff.
And powerful. Yet, amidst all these vast cosmic questions, there's also a strong sense of humility in knowledge.
Even from Hawking.
Especially from Hawking, he constantly reminds us, gently, that our knowledge is incomplete. There's so much we don't know.
Which is kind of exciting in a way.
That's exactly his point, that incompleteness is what drives science forward. It's a journey, not a final answer.
Which brings us back to how he did it. His approach. Making the complex accessible. What were his main tools?
Well, his writing style was key. Very clear, direct language.
And famously, almost no equations.
Right. Except for the icon itself, EMCIAC. But his real magic trick was analogies.
Ah, using relatable comparisons.
Exactly, like comparing black hole evaporation, that Hawking radiation.
So just a hot object glowing.
Yeah.
Radiating heat.
Precisely. It gives you an intuitive handle on a deeply counterintuitive idea. It's brilliant. Makes you feel like you get it without needing the complex physics.
That's incredibly effective.
It is, though it's fair to say he expects something from the reader, too.
What do you mean?
He acknowledges that some concepts need what you might call active reading. You might need to slow down, maybe reread a section.
It's not dumbed down then.
No, not at all. It's approachable, but it respects the complexity. It engages your brain.
So, looking back now, decades later, what's the lasting impact? Why is A Brief History of Time still relevant? What are its biggest strengths?
I think its main strength is still how well it bridges that gap. Science, complex science, and the general public, that's huge.
And the core ideas haven't really aged.
Most of the concepts he discusses, they're still fundamental pillars of physics today, so it has this timeless relevance.
It must have inspired a lot of people.
Oh, millions. It sparks that sense of awe, curiosity about the universe, about existence itself. And there's a very personal element, too.
Hawking's own presence in the book.
Yeah, his wit, his optimism, it shines through, even with everything he was dealing with physically. You connect with him, not just the ideas.
And the impact, numbers-wise, it was massive, wasn't it?
Absolutely huge. Sold over 25 million copies globally.
Wow.
Inspired countless people, kids, students, adults, even scientists to get interested in physics and astronomy.
And it made Stephen Hawking himself a household name.
An international icon, a symbol of what the human mind can achieve, of perseverance.
Okay, but are there any, maybe, limitations? Things a modern reader should keep in mind.
Sure, a couple of minor things. Some bits, like maybe parts of the quantum mechanics chapters, can still feel pretty abstract if you have zero background.
Despite his best efforts.
Despite his best efforts. And naturally, science has moved on since 1988.
Right, so it won't cover things discovered since then.
Exactly. Discoveries about dark energy, for instance, or detailed findings from gravitational wave detectors, those aren't in there.
And maybe for someone already deep in physics, it's more of an overview.
Yeah, for an expert, it's a primer, but that wasn't really its main goal anyway.
Makes sense. Okay, so tying it all together, who is this deep dive really for? And who is the book itself for? How can it help different kinds of people listening right now?
Good question. Let's break it down. First, students. High school, college, even later.
What's in it for them?
It gives you a fantastic foundation in modern physics. Concepts like relativity, quantum mechanics, it lays them out clearly, and it can be hugely inspiring.
You mean like sparking a career path?
Could be. Imagine a teenager reading this, getting hooked on space and deciding, yeah, astrophysics, that's for me. Or just gaining confidence to tackle any complex subject.
Okay. What about just curious general readers, people who like learning but aren't students or scientists?
For them, it demystifies these big, often intimidating ideas. It strengthens your whole worldview, gives you a sense of context.
Context for humanity's place in it all.
Yeah, in the grand cosmic scheme. Plus, hey, you could explain Hawking radiation at your next dinner party.
Huh. Impressive. What about lifelong learners and thinkers? People who just love stretching their minds.
Oh, it's perfect. It's a real mental workout, but in the best way. It offers a massive perspective shift.
How so?
Reading about the birth and death of the universe, it can give you this profound sense of wonder about life, how fleeting, how precious our little moment is. Deeply fulfilling.
That sounds powerful. Now, what about aspiring or early career scientists? They probably know some of this already.
It's true, but it offers something else. Inspiration in how to communicate science. Storytelling.
Ah, seeing how Hawking did it.
Exactly, an interdisciplinary awareness. Plus, Hawking himself is just such a powerful role model. Persistence, curiosity. It's not just about the math.
Communication is key.
Crucial. Okay, then there are philosophers and deep thinkers.
How does it connect for them?
It bridges science and meaning directly. It challenges basic assumptions about beginnings, endings, time itself.
Grounding philosophical questions in actual physics.
Precisely. It adds this essential scientific layer to those deep, timeless debates. Broadens the toolkit.
I can definitely see science teachers and educators finding it useful, too.
Oh, absolutely. It's a goldmine for clear explanations and analogies.
Like the expanding universe as a balloon.
That's a classic Hawking analogy. Teachers can borrow those models to make abstract concepts like relativity or quantum uncertainty click for their students. Boosts engagement.
Makes learning more visual, more memorable.
Definitely. And finally, maybe unexpectedly, it's for people seeking motivation and resilience.
Because of Hawking's own story.
Yes. His personal journey, overcoming ALS while exploring the cosmos, it's incredibly inspiring.
A reminder that limitations don't have to define you.
Exactly. Physical limits don't need to stop intellectual adventure. People facing challenges can draw real strength from his example as much as from his scientific ideas. It adds another layer entirely.
So let's sum up our final verdict, based on the review, for A Brief History of Time.
It's a very strong 9.5 out of 10. Highly recommended.
And best for.
Really, for anyone who wants to unlock the universe's secrets, but doesn't want to get bogged down in complex mathematics.
Got it. And the biggest single takeaway from our deep dive today?
I think it has to be this. The more we learn about the universe,
the more we realize how much we don't know.
Exactly. It just opens up more questions, bigger frontiers. It's an endless journey of discovery.
Okay, so we'll leave you, our listener, with a final thought to chew on.
Reading A Brief History of Time or engaging with these ideas like we've done today, it's not just about learning science facts.
No, it's more fundamental. It's about learning to think bigger, to question deeper.
To live with more curiosity.
It changes how you see everything. It turns the universe from this distant, abstract thing into a personal adventure, an ongoing exploration.
And the reward, it's a richer sense of reality and your own unique, amazing place within it, no matter who you are.